All right, welcome back again. So now we're going to expand on what we did on 9.3 AC. Instead of having, we're changing our restrictions in our domain. So instead of only allowing things in the first and fourth quadrant for sine, we're now allowing it to anywhere in any quadrant. So that gets us into a little bit of discussion. So a lot of times, if it's not quadrantal, I shouldn't say a lot of times, always, if it is not quadrantal, there's going to be two answers. Okay? And so we'll get into that as we go here, but you're allowed to use all four quadrants now. This is what I would write on a test or a quiz when I'm changing the domain. 0 to 2 pi means all the quadrants are now in play. Well, there is a mnemonic device, sometimes that you would use to try to memorize what you would do. So all of them are positive in the first quadrant. So if I give you a positive ratio, all of them, sine, cosine, tangent, cosecant, secant, and cotangent, are all positive in the first quadrant. Now let's talk about where the other ones are positive. Sine, and then therefore cosecant, is positive in the second quadrant. Tangent and cotangent are the only ones that are positive in the third quadrant, and cosine and therefore secant is positive in the fourth quadrant. So now, how do they memorize that? All students take calculus. All of them are positive in the first quadrant. Sine is positive in the second. Tangent is positive in the third. And calculus, C, cosine, is positive in the fourth. So again, if you wanted to know where are things going to be positive, all students take calculus are the quadrants in which things are positive. So now, just like before, I'm going to give you a ratio. You are now going to have to draw the ratio in two different quadrants. It's positive. So one quadrant for positive is the first quadrant, adjacent, hypotenuse. Now, negative and a negative. Think about this now, or excuse me, where else would something also be positive for the adjacent and also positive for the hypotenuse? You're talking about the fourth quadrant. All students take calculus. C, the fourth quadrant, also has a square root of 3 over 2. Remember, hypotenuse is always positive. So now, writing the missing side, this makes a 30-degree reference angle. Now, this gets a little bit mean here, but I want this in radians. So 30-degree reference angle in radians is pi over 6. Now, instead of just saying negative pi over 6, they want the positive. So again, positive, going all the way around 330 degrees, is a 11 pi over 6. So there are two answers to this question. One is positive pi over 6, and the other one's positive 11 pi over 6. So again, going around, getting two answers. All right, it's unrationalized. So instead of this square root of 2 over 2, I'm going to write this as negative 1 over the square root of 2. I need an opposite and hypotenuse. It's negative. So opposite is negative. And so then another one where an opposite would be negative would be in the fourth quadrant. So these are two quadrants in which the opposite is negative and the hypotenuse is positive. And remember, the hypotenuse will always be positive. Find the missing side. So the missing side is 1. It's a 45-degree reference angle. All right, so here's what I want. I want to know what this angle measure would be in radians. Every fourth is a 45-degree reference angle, so we're talking about 5/4, because it's 1/4 past 1. And the other one then would be 7/4. So going around every fourth. Okay, so 1/4, 2/4, 3/4, 4/4, and so on. Question. Hopefully, if you have a question about this, make sure you're asking. Arc cosine, again, we got to remember your restraints. You got to understand that is all the way around the triangle. Or excuse me, all the way around the circle. Negative and cosine. So we're talking about adjacent being negative and hypotenuse being positive, adjacent being negative and hypotenuse being positive. The missing side on this is the square root of 3. So one's positive, one's negative. That's a 60-degree reference angle. So now you're talking about a third. So again, this angle measure in radians would be 2/3 pi, and this angle measure in radians would be 4/3 pi. Unrationalized, so this would be 1 over the square root of 3. It's positive. So you're talking about the first quadrant, where the opposite side is 1, the adjacent side is the square root of 3. Well, the only other location in which tangent is positive is down in the third quadrant. Reason is because if the opposite is negative and the adjacent is negative, that would then be a positive again. So the missing side on both of these is 2. That makes a 30-degree reference angle. So here we go in radians. Every 30 is a pi over 6. So this is 1/6 pi. And then this one then would be 7/6 pi. How do I know that so quickly? Remember, you're going past 1 pi by a sixth. So this is 1 pi. 1 pi is 180 degrees. So I went past it by 1/6. So 1 and 1/6 pi, which is 7/6. Don't write it as 1 and 1/6. Write it as a improper fraction. Cosecant of 2. So now this is 2 over 1, which is positive. Cosecant would be hypotenuse over opposite. So you're talking about the hypotenuse over the opposite. So where else can I get an opposite that's positive? I apologize for that. Opposite is positive. Hypotenuse is positive. So now the missing side is the square root of 3, which makes a 30-degree reference angle. All right. So now I want the angle measures in radians. So this, every sixth, is a 30-degree reference angle. And so this would be 5/6. So again, understanding that every sixth has a 30-degree reference angle will then get you to the correct fraction that you need. Negative square root of 2 over 1. It's negative, and it's secant. Secant is hypotenuse over adjacent. So I need a hypotenuse and an adjacent, which would then also be in the third quadrant, hypotenuse over adjacent. So this is a 1, 1, square root of 2, which is a 45-degree reference angle. So now 45 is a fourth. So this would be 3/4 pi. And then past this would be 5/4 pi. Now you're going to get into your quadrantals again. So this gets a little bit more confusing. Anytime you have sine, and we did this on the last video, but anytime you have sine that's 0, 1, or -1, it's quadrantal. Anytime you have cosecant that's 0, 1, -1, it is quadrantal. Anytime you have cotangent or tangent, okay, and I should say cosecant, secant, 0, 1, -1, and undefined. Anytime you have cotangent or tangent as 0 or undefined. Notice I did not say 1 for tangent. Okay, tangent with 1 is actually a 45-degree angle. So now I see an arc sine of a 0, so I know that it's quadrantal. Here's what I would tell you. If you end up knowing something is quadrantal, automatically revert to the unit circle. Sine. On the unit circle, sine is always the y value. So I'm looking for a y value of 0. Y value of 0 is located in 2 locations. Remember, our restraints now allow us to do 2 locations. And so now, 0 is an answer. Okay, so if you don't move at all, if you go 180 degrees, which is pi, that's an answer. And technically speaking, 2 pi would also be an answer. Given your restraints are from 0 to 2 pi, 0, pi, and 2 pi would be an answer. All right, arctan undefined. So I know that's quadrantal. So I'm going to draw in the unit circle, and I'm going to put the points that are on the axis from the unit circle. Tangent is always y over x. So in order to get a tangent that's undefined, the x values have to be 0. So where are the x values? 0 is at 90 degrees, which is pi over 2, and at 270 degrees, which is 3 pi over 2. Okay, so I bet you if you hit second tangent of 90, you'd get an error on your calculator. So just letting you double check that I'm doing this right. Okay, second tangent 90 degrees is undefined. All right, unrationalized, and this is where things start really getting going here. So I get 2 over the square root of 3. Cosecant is hypotenuse over opposite. So you're talking about the hypotenuse being 2 and the opposite being the square root of 3. Well, where else can I get an opposite being positive? Okay, and the hypotenuse being positive would also be in the second quadrant. Fill in the missing side. This is a 60-degree reference angle, so we're talking about a third. So pi over 3, that would be the first 60-degree angle, and 2 pi over 3, that would be the second. Arc cotangent, -1. So again, this is the only time tangent and cotangent can be 1. So I need adjacent over opposite. So adjacent over opposite being -1. And then that would also be up here with the adjacent over the opposite being -1. Fill in the missing side. That is a 45-degree reference angle. Every 45 is a fourth. So now that angle in degrees, or excuse me, in radians would be 3/4 pi. This angle measure in the fourth quadrant in radians would be 7/4 pi. So again, understanding that every fourth has a 45-degree reference angle is going to be very beneficial to you. Again, homework assignment 9.3 AC day 2. Now we just change the restraints. So instead of getting only 1 quadrant for each answer, now you're going to have 2 quadrants for each answer. Please make sure you're talking to Ms. Kinsel and myself about any questions you have. Again, this can be complicated. Reach out to us. We are there to help. Good luck. Be safe.